Hi, welcome to online tutorial videos from JCB Labs. For more information, you can visit us at www.jcbrolabs.org. You can also mail us at info@jcbrolabs.org. In this video, we are going to demonstrate a new project which is WCA optimized fractional order PID controller for rotatory inverted pendulum. Apart from that, further we also provide online training, help in technical assignments. We also do freelance projects based on data science, Python, machine learning, embedded system, etc. So if you have any such requirement, you can let us know by contacting us through our website, which is www.jcbrolabs.org, or you can also mail us at info@jcbrolabs.org. So I hope you are very much familiar with the normal inverted pendulum systems, and that forms a classic problem for the control systems in control system engineering, and a lot of different algorithms like PID controller and other optimization algorithm are being tested to apply their effectiveness to the control of this inverted pendulum. Now, similar in the series of this inverted pendulum, there is another class of inverted pendulums is rotatory inverted pendulum, and that is also very highly non-linear system, right? So a different kind of control algorithms can be developed to control the position and the angle of this rotatory inverted pendulum. So in this project, we have implemented this journal paper, right? This is from Arabian Science and Arabian Journal of Science and Engineering, right? And the inverted pendulum which we are going to talk about is similar to this structure as shown in this figure C, and the transfer functions which we have used are similar to the transfer functions which are represented by this equation 9 and 10, right? And then we have developed our fractional order PID controller with the help of FOMCon toolbox, and then we have used the water cycle algorithm, that is WCA optimization algorithm, to tune the different parameters of this fractional order controller so that we get a better response. That means better step response and zero disturbance, right? Okay, now let's see the model which we have created here. So here is Matlab, this is our model, right? And these are the transfer functions. First is this theta link, and then this is the pendulum angle. So we want our pendulum angle to be 0, and the theta link angle can be provided anything which we want to provide. Let's say we want this link angle to be 30 degree, 40 degree, and so on. Okay, so right now this link angle is in radians, right? So this is similar to this transfer functions which we have seen here. Yeah, this transfer function, figure D, right? Okay, so these are the reference positions. So our angle pendulum position is 0, and our theta reference position is, we are providing a value of 1, so because we are taking the step response in consideration, right? And if we right now if we look at the output, okay, so we have simulated this model, we have already optimized. We will also show you the optimization result. So this is the final result of this model, okay, which we obtained after optimization. Okay, so now we will also run the optimization. So this is the optimization code which we have created, so we can't show you the entire thing here, right? Because if you need these project files, you can contact us at our mail ID info@jcbrolabs.org, and this is the objective function which we have created. So in order to optimize the parameters of this PID controller, you just have to run this algorithm, and then it will start optimizing it. Okay, so you will see, so these are the final result which we obtained after optimization. So okay, we showed those results because let's say because optimization takes a lot of time, and we may have to terminate the entire video in between. Okay, so right now optimization is running, and the same is, you can see the results, and these are coming and not coming because the optimization algorithm is trying to tune the parameter of the FOPID controller. So what exactly the optimization algorithm do? It generates the different values of KP, KI, KD, lambda and mu for both the controllers. So there will be total 10 different parameters which needs to be optimized. So it will be generating different values of this KP, KI, KD, lambda and mu, and then applying it to the model and then observing the output of the model. So obviously for some values model will not give satisfactory output, and for some values it will give satisfactory output. So by and large, at the end of the optimization algorithm, it will give us the satisfactory result. So let's minimize it. Okay, here it is running. So it is the model which is running. So you can see here it is compiling and running each time. Okay, now let's we can close this window so that we can get the model will run much faster, right? Okay, so we have closed that window. Now only the model is running. So if you close the model as well, the entire optimization algorithm will run more faster. Okay, so first iteration results are there. So first iteration result is 7710. So in this case we have used FITAE as the objective function. So these are the values. 12,710, it is the ITA value, and if we scroll it up, you will see different values of the function. So this was the minimum function, because we run prior to making the video, we run the model at our end, and this is the minimum value which we received prior to making the video. Okay, so let's wait for some time. Okay. Okay, so it's working. Okay, so look at within the third iteration, the value has reduced by a lot. Okay, so it will take time. So let's cut it, or let's stop the execution. Okay, so we have stopped the execution in between. That's why this command we are seeing. So we are pressing the Control C command here. Okay, let's press it. Okay, now it will terminate. So you have seen the output and the model in working stage. So it is working perfectly fine. So if you want these project files, you can contact us at info@jcbrolabs.org, and then we will send you all the project files related to this project, and we will also provide online support as well. So if you face any difficulty while running this project file at your end, we will provide you online support. So yeah, that's it for this video. Finally, we also provide online training, we also do freelance and industrial projects based on data science, Python, machine learning, embedded system, etc. So if you have any query related to any of these topics, you can contact us through our website, which is www.jcbrolabs.org, or you can also mail us at info@jcbrolabs.org. So thank you, have a nice day, bye.